Newton's first law today. Newton's first law states that every object in this universe continues its state of rest or of uniform motion in a straight line unless acted upon by some external force. For example, we consider this shopping cart that is lying here. The man is not pushing the shopping cart, and hence the shopping cart will lie here for 15 more years if he is not touching it. Until and unless nobody comes and applies a force to the shopping cart will not move. In this case, we say that since no unbalanced force is acting on the shopping cart, the cart is not moving. While in the other case, we can see that the shopping cart is moving. That is because the boy has applied some force on it. The man is pushing the shopping cart with a force. And that force is unbalanced force which makes the object move. So we should remember that if a pair of balanced forces are acting on an object, the object will not move. However, if there is an unbalanced force acting on an object, the object will start moving. By unbalanced, we mean that one force is bigger and the other force is smaller. Same thing is applicable to something that is in motion. For example, a ball is rolling. The ball will keep on rolling until and unless the frictional force makes it stop. Now imagine a world where there is no frictional force. The ball is not going to stop at all. That means a force is required to stop that object. Thus, Newton's first law is applicable to both the kinds of objects, the objects that are at rest as well as the objects those are in motion. So Newton's first law says that any object that is at rest will continue to be at rest until an external unbalanced force acts on it. He says the same thing for objects in motion. An object in motion will continue to be in motion unless an external unbalanced force acts on it. Newton's first law defines a new quantity that is known as inertia. What do we mean by inertia? Mass of an object is a measure of inertia. More the mass, more is the tendency of body to stay in its state of rest or in uniform motion. If we take the simplest example of a truck and a cycle, it is very difficult to move the truck because it has a greater inertia on account of its mass. So it tries to remain in its state of rest. Same thing. It is difficult to stop a moving train because train has more inertia on account of its more mass. Hence, it tries to continue it has a tendency to remain in a state of motion. Thus, inertia is measured by the mass of the object, and Newton's first law defines inertia. Inertia are of three kinds: inertia of rest, inertia of motion, inertia of direction. We are talking about inertia first and then we shall come to its types. Inertia, the tendency of a body to continue in its state of rest or of uniform motion in a straight line even when some external unbalanced force acts on it, is known as inertia. So, there are certain objects on which we do apply a force, but still they cannot change their state of rest. That is because of inertia of rest. If we apply a force to an object and it cannot change its state of motion, that is due to inertia of motion. Also, if we apply force to an object to change its direction and it cannot change the direction, that is due to inertia of direction. So, first one, inertia of rest. An object will continue to be at rest even when a force is applied on it. For example, consider this example where we take a glass, we put a cardboard in it and we put a coin on it. Very quickly, we flip the cardboard over here. Now, the action is done so fast that the coin does not realize there is an external force acting on it. The coin remains in its state of rest and it falls down into the glass. This is an example of inertia of rest of the coin. We must have also observed that when we are traveling in a car or in any vehicle and suddenly the car starts, So when a car or a vehicle starts suddenly, we get a jerk in the backward direction. That is also due to inertia of rest. Now what happens that when the car suddenly starts, the lower portion of our body comes into motion, while the upper portion of the body is still at rest due to inertia of rest, and hence we get a jerk in the backward direction. These are few examples of inertia of rest, and the object is trying to continue its state of rest. Inertia of motion. A similar example here. An object continues to be in motion even when a force is applied on it. So if you are moving in a car, this is an example. If you are moving in a car, the car is already in motion. That means our body also possesses inertia of motion. Suddenly the brakes are applied. When the brakes are applied, the lower portion of the body comes to rest, while the upper part of the body still continues to be in motion, and we get a jerk in the forward direction. That is due to inertia of motion. One more example here. There is a boy who is cycling. Suddenly there is something that comes in front of his tire. He will trip and fall in the forward direction. That is because of inertia of motion. Again, when the cycle is suddenly stopping, his lower body comes to rest, but the upper body is still in motion owing to inertia of motion. And hence, he gets a jerk in the forward direction and he falls forward. Third kind of inertia is inertia of direction. An object continues its direction in a straight line even when a force acts. This is the tendency of an object where it cannot change its direction easily even when the force is applied. For example, you are standing in a bus. Your body is in motion along with the bus in that particular direction. Suddenly the bus takes a sharp turn and we get a jerk sideways. Our body starts swaying sideways. That is due to inertia of direction. So inertia are of three kinds: inertia of rest, inertia of motion, inertia of direction. Remember, inertia is given by Newton's first law. We come to a new quantity that is known as linear momentum. Linear momentum is defined as the instantaneous force that a body possesses due to the combined effect of its mass and velocity. Linear momentum is a combined effect of mass and velocity. Here, the equation of momentum is P is equal to m into v. When we take the mass of the object and we multiply it by the velocity with which the object is moving, we get the momentum of the object. It is a combined effect of mass and velocity. So, obviously, it depends upon two factors. It depends upon the mass of the object and it depends upon the velocity of the object. SI unit for momentum. Okay, if you take the SI unit of mass, it will be kilogram. The SI unit of velocity will be meter per second. So it should be kilogram meter per second. Kilogram meter per second is also known as Newton second, like it's written here. While the CGS unit will be gram centimeter per second, which is also known as dyne second. Again, linear momentum P is equal to m into v. That is combined effect of mass and velocity of the object.